All right, we are going to review. We're going to have a test tomorrow, and we are going to review for that test. And the test really centers around 3 basic tools that you can use to know the measurement of angles. So we have 2 lines here, and I'm going to tell you right now that these lines are parallel. Let me just write this up here. These lines are parallel lines. So we know that if you look, I can select this one and I can show that this one's a translation of, you can translate it down. And so we know that those 2 sets of lines are congruent. Okay. There are 3 or 4 kinds of angles on here that are all congruent with each other. So first we have the corresponding angles. Those are the ones that were translated down. So 1 and 5 are corresponding angles. They're in the same location on both lines, and they have the same measurement. They are congruent. Another set of corresponding angles is 2 and 6. If you move this down again, you'll see that 2 is right on top of 6. So those 2 are the corresponding angles. So I'm going to write another little thing over here. 2 and 6 are corresponding. Okay. Another set of corresponding angles is 3 and 7. 3 and 7 are corresponding angles. Whoops. And then the final set of corresponding angles are 4 and 8. You can see that 4 goes down and it would be in the same position as 8. So all these green ones are the corresponding angles. I'm going to go through them. I'm going to erase them because we're going to do the next color, the next set of angles. We're going to look at the alternate interior angles. So we have this diagonal line going down. It's the transversal. So the transversal cuts through the 2 parallel lines. And if you have angles that are on opposite sides of that transversal, they're considered alternate angles. An interior means, this interior means that they are on the inside here. This is the interior, like the interior of my Oreo, the interior of my house. So there are only 2 sets of alternate interior angles. We have 3, and then on the opposite side of the transversal, still on the inside, is 6. So 3 and 6 are alternate interior angles. And then the other set that we have, if we go back to our pencil, we have 4. Let's hop over this transversal and go down, and looky, there's 5. So 4 and 5 are alternate interior angles, and they are always going to be congruent. And the reason that they're going to be congruent is because there's a rigid transformation that takes one to the other, but also because 1 and 5 are congruent and 1 and 4 are congruent. We're going to talk about that one in a second. And so, or actually 3 and 7 are congruent, 4 and 8 are congruent, and they all have to be congruent. I'm like tripping over my words here. We know that 1 and 4 are congruent. We know that 1 and 5 are congruent. So 4 and 5 have to be congruent. There, got that one out. So I need the other set of alternate interior angles, and that's 4 and 5. So I'm going to erase my blues. So that we can go on to I'm going to do the alternate exterior yet. Alternate still means on opposite sides of that transversal. Still have our transversal, still have opposite sides, but now we're on the outside. This is the outside, this is the exterior. So are on the opposite outside. So we have number 1. And then on the opposite side of the transversal, still on the outside, is 8. So the alternate exterior angles that are congruent with each other are 1 and 8. So why are 1 and 8 congruent? Well, because they're alternate exterior angles. We also know that 1 and 5 are congruent because we translated 1 down to 5. We know that 5 and 8 are congruent because they're vertical angles. And so we know that 1 and 8 have to be congruent. All right, let's look at 2. 2 is another one that's congruent. Or that's an exterior angle, and its congruent exterior angle is 7. So 2 and 7 are congruent. But now I need to look. I put the vertical angles over here. And the reason that I put the vertical angles over there is because it does not matter if our lines are parallel for the vertical angles. It does matter if they're parallel for the alternate exterior, alternate interior, and whatnot. If the lines are not parallel, then it means that the translation did not take place. There was not a rigid transformation taking us from one to the other. And so we know that those lines are not parallel. I'm going to replace my little number 2 here because it got messed up. All right, so let's look at these vertical angles. Now I'm going to draw just a random pair of vertical angles over here that does not have to do with our translation over there. So if I look at A, B, C, and D, I can see that A and B are on a straight line. This is another one of our angle relationships that this unit really, really relies on, that the two angles on a straight line, A plus B, have to be 180. They have to be. We have no choice because they're on a straight line. We also know, though, that B and C are also on a straight line. So B and C are on a straight line, so B plus C is 180. Well, if A and B equals 180 and B plus C is 180, then A plus B will equal B plus C. I can subtract B from both sides. And then if you discover at the end, A is going to equal C. If we have two angles on either side of this vertex right here, where they crisscross, we have A on this side. Here's A. Actually, I think vertical angles were purple, weren't they? So here's A on this side. And here's C on this side. Those angles are going to be congruent. It doesn't even matter if we have parallel lines over here. And then we have B over here, and B and D are congruent. So let's look up here. So we have 1. Where is 1's vertical angle? Well, it's right over here with 4. So 1 and 4 are congruent. Is there another set of vertical angles? Let's see. We have 2 and 3. 2 and 3 are going to be vertical angles. And then down here, we have 5 and 8 is across that vertex. And then the last set is going to be 6 and 7 are vertical angles. So to circle them over here. So those are our vertical angles, are 6 and 7. So let's look though. We have another concept. So we have the lines on a triangle, or the lines on a straight line. The angles on a straight line are 180 degrees. We know that we have these parallel lines relationships. Then we also have the fact, don't save. We also have the fact that the angles on the inside of a triangle are always going to be 180 degrees. Now this one, I know that this is 90 degrees. I am going to estimate that this one's probably 70 degrees. So can I figure out what angle X is? Sure, because I know that the interior angles of this triangle all add to 180 degrees. I can say 90 plus 70 plus x equals 180 degrees. Let's combine some like terms over here. 90 plus 70 is 160 plus x equals 180. Got to isolate that variable. We have added 160, so we're going to subtract 160. And we end up with x equals 20 degrees. And we do the does it make sense test. We've got a nice little acute angle up here. Could this be 20 degrees? Totally, this could be 20 degrees. I'm going to circle it. So let's practice a minute. And we've got some angles here. So we're just going to see if we can figure out what they are. I'm going to use green. So we've got parallel lines. All of these lines are parallel. This one's 60 degrees. Oh, I've got a corresponding angle, so this one's 60 degrees. I've got this one's 130 degrees. This one's a corresponding angle, so it's 130 degrees. Let's go over, let's do one more. This one's 40 degrees. This is his corresponding angle. So this one, I'm going to draw a little line, is 40 degrees. Let's look over here. This one's 48 degrees. This one's an alternate interior angle. It's going to be congruent, and it's 48 degrees. This one's 138 degrees, and this one, they're on the same side of the transversal, so they're not alternate interior angles. So what is z degrees? How do I do this? Well, I know that 138 is alternate interior angles with this one, so that's 138. I know that this is a straight line, so 138 plus z equals 180. We've added 138 over here, so now we're going to subtract it to get the z alone. And z is going to be equal to, I'm going to put it up here, 42 degrees, because 180 minus 138 is 42 degrees. Let's do, I don't think we're going to do all of these, but these are a good little review for your review. Let's do one more. So here we have, this is 60 degrees. This is x. It's on the same side of the transversal, so we know it's not congruent. You can see that it's not congruent, right? 60 is an acute angle. X is an obtuse angle. There is no way that they can be congruent. But I know that 60 degrees is congruent with this guy because they're alternate interior angles. And these guys are on a straight line, so they add up to 180. I'm going to come down here. So we have 60 plus x is 180 minus 60 minus 60, and then we have x equals 120 degrees. Now let's look. Does this make sense? Does it look like this could be 120 degrees? Oh, totally. That looks like it could be 120 degrees. It's bigger than 90, but not crazy much bigger than 90. X is 120 degrees. We've got some over here that are, ooh, this is kind of hard. Or is it? Can we do this? Let's see. We've got these, and we know that these are actually parallel lines, okay? So we need A, we have 50 degrees. So I know that the interior angles of a triangle, I've got a triangle here, they add up to 180, and I can do this, except that I have a little problem that I don't know this angle, and I don't know this angle, and I need to have at least two of the angles to be able to find the third one, so that's not gonna work for me. But I do know that these are parallel. And this kind of looks like it might be like a transversal for me. You see that? See how this could be a transversal? So we've got a transversal coming down, and these are on opposite sides of the transversal. So this one's 50 degrees. This one's also 50 degrees, and I didn't even have to use the fact that it was on a triangle. I didn't even add to 180 degrees. Let's look at number 5, and then I think we'll be good to go. Let's see. I know that these lines are parallel. This line is not parallel, but it's a transversal coming down. I'm just going to extend it out a little bit. I know that this is 40. I know that this is 60. I know I have a triangle here. Let's see, what can I do? So these are, this one and this one are alternate interior angles. So 40 and x are alternate interior angles, so x is 40. But I don't know y and z. And I know that the interior angles on a triangle add up to 180, so I could have 40 plus y plus z equals 180, which is great, but I don't know y and z. Let's see what else I know. I know that this is on a straight line, and I have 40 and x, and or I have y and 40 and 60 equals 180. That one I can figure out. Y plus 40 plus 60 is 180. Y equals 40 plus, y plus 40 plus, or 40 plus 60 is 100. I'm just going to like add that together right now. Y plus 100 equals 180. I've added 100, so to get rid of it, I need to subtract 100. I have to do it to both sides so we maintain that equilibrium. And y equals 80. Does that make sense? Well, sure, it's smaller than 90, but not a lot smaller than 90. So y being 80 works. And now I can use this y and this 40 degrees to figure out z. So 40 plus 80 plus z equals 180. I'm going to bring this up here since I already filled up my space down here. 40 plus 80 is 120. Plus z equals 180. Minus 120. Minus 120. Z is equal to 60. There we go. Does that look like it could be 60? Sure it does. Oh, and actually look what I just noticed after going through all that work. I've got my parallel lines right here, right? This could, we've got our transversal z and this 60 are actually corresponding angles that I didn't even notice. Well, I hope this helped you with your review. The review is extremely much like the test. If you can do the review, you can do the test. If you can't do the review, you can't do the test. So if you run into stuff on the review that you need help on, please let me know. Good luck and have a lovely day.